Hey, what's up everybody? Welcome back. Lesson 46 here of the Dead Earth game development series, brought to you by the Game Institute. I'm Gary Simmons, and in this lesson we're going to start designing the system that's going to allow our zombie to play all of its various sound effects, and that's going to be using the audio collection scriptable object class that we wrote in the last lesson. Most of the sounds are going to be triggered from state machine behaviors that we add to our animation states. So the way it's going to work is we're going to add curves to our animations, and those curves are going to describe to the various state machine behaviors on our animations which bank it should sample an audio clip from in whatever audio collection we've assigned to that state machine behavior. Now, the state machine behavior we're going to write is going to be called audio collection player, and we're going to write that in a minute. And we're going to first start off concentrating on just the first two layers of our animator, which are going to be predominantly responsible for creating the zombie's footstep sounds. So we're going to need a zombie footsteps audio collection. Now, if I look in my sounds folder and in my audio collections folder, you will remember that we have an audio collection already called player footsteps, which we're using for the player. And I did say in the last lesson that all of these same audio clips are also going to be reused by our zombies for their footsteps, but I don't want to use this exact same collection because this collection has been assigned to the player audio group and has also been assigned a priority of 256, very high priority. I want my zombie footsteps to essentially be a duplicate of this, but with the audio group set to zombie and with the priority set down to the default of 128. So let's do that before we go any further. I'm going to select my player footsteps audio collection that we created in the last lesson, and I'm going to duplicate it, and I'm going to rename this one Zombie Footsteps. Then with Zombie Footsteps selected, in its inspector, I'm going to delete player for the audio group, and I'm going to replace that string with zombie, so that the sounds in this collection are routed through the zombie audio group on our audio mixer. I'm also going to slide the priority down to 128. In fact, I'm going to type it in because that's quicker, isn't it? Yeah. So the next thing I'm going to do is I'm going to turn off all of the other zombies in my scene except Jill. Now, you will remember that when we were working on just Jill originally, we got the animator controller how we wanted it, which was called Omni Zombie 1. And then when we had it completed, I duplicated it 3 further times. So I had 4 animator controllers. And then what I did was just spent 10 or 15 minutes swapping out some of the motion fields so that each controller had different animations. And that's how we created a variety of animations being used by all our zombies. However, in this lesson, we're going to have to add an awful lot of stuff to our animator controller. We're going to have to add state machine behaviors to most of the animations, and they're going to have to be configured. So I don't want to have to reflect all those changes back over those other controllers when I'm done. So what I'm going to do eventually is delete those other 3 controllers, and then once I have our Omni Zombie 1 controller fully configured and making all of the sounds in the correct way, I'm then going to duplicate that controller just like I did before to create 3 other controllers. And then I'll just repeat that process of going back into those controllers and spending 10 or 15 minutes just swapping over the motion fields again. So I'm going to turn off all of the zombies except Jill, like I said, and we're just going to be working on Omni Zombie 1. Which is our first controller. And we're going to predominantly in this lesson be working on the base layer and the lower body layer, which are going to be responsible for the most part for the footstep sounds, because these layers are the locomotion layers. So in order for any of our state machine behaviors to get access to the values of curves on our animations, we have to marry up the curves on our animations with like named parameters in our controller's parameter list. So I could create, for example, a footsteps parameter, which is being used to keep track of a footsteps curve on our animator, and then we'd need an attack parameter, and then maybe a screaming parameter, and then maybe a hit parameter, and then a number of other parameters that will keep track of sounds that need to be made for various different cinematic sequences that are happening. But it sounds kind of messy and a bit too specific. Fact of the matter is, most of the time, the animation sequences that are going to be happening on each layer won't be happening at the same time, so some of those parameters could be reused to carry information between different types of animations. So what I'm going to do instead is I'm going to create a few generic parameters that we can use for our system. So I'm going to create 4. I don't even think I'm going to need 4. And I'm going to call these parameters command channels. So I'm going to go to my parameters list, and I'm going to create a new float parameter, and I'm going to call this first one com channel 1. I'm going to create another float parameter and call this com channel 2. Another one called com channel 3. And a fourth one called com channel 4. And I think that's probably more than we'll ever need. So all we need to be clear about before we author our curves is which com channels we're going to use to carry which information to which layers. So for example, what I'm going to use is com channel 1 for relaying all of my footstep information to the base layer and the lower body layer. But for our attack layer, well, we can't use com channel 1 for that because the attack animations need to be playing out and carrying different information to our base layer, even though they're going to be playing at the same time. So if we had the base layer active and the attack layer active, and both of those animations had curves that were modifying com channel 1, then probably none of them are going to get the actual information that they want. But in other scenarios, such as when our cinematic layer is active, we don't really care what's happening in any of the layers underneath it because the cinematic layer overrides everything. So when that's the case, we could, for example, for these animations, quite happily use com channel 1 to carry any information we want to its scripts. So what I'll do probably is have the base layer and the lower body layer listening to com channel 1, or any animation that needs to make footsteps, but the attack layer, which needs to happen simultaneously, will send its information on com channel 2. So as long as we know that going forward, we know what to call the curves in the animations when we create them. Now, there is one thing we need to be cautious about when we're showing parameters across layers in this way, and that is that just because a animation layer has been set to override the layer underneath it, it doesn't mean that the script on those states are still not being executed. So even if we turn up our lower body layer so that this zombie walk animation is completely overriding the zombie walk animation on the base layer, the zombie walk animation state is still being executed. It's not contributing in any way to the animation of the character, but any scripts on it will still execute, and we've seen that with our root motion configurator scripts. So we need to make sure that whatever we do with our parameters plays nicely with that system. Now, it just so happens that the controller is clever enough such that, let's say for example, this zombie walk animation on the base layer has a curve defined in it called com channel 1. We know that when this animation is playing, it's going to be sending in values to our com channel 1 parameter, and we'll say for example it's going to go to a 1 whenever a footstep sound needs to be played for that base layer animation. Okay, now let's also assume that we get lower body damage and we put up the lower body damage weight to 1. And now, of course, it's this second zombie walk animation that is overriding the one on the base layer. And we don't want the footsteps being played for the base layer, but both of these animations are technically having their scripts executed, and of course both of those animations have curves on it that are sending values to exactly the same parameter, which is com channel 1. So it's not a problem. We can stop the script executing on the layer underneath it. We can say in the base layer, hey look, if the lower body layer is active, then don't play any sounds and do anything like that. But we do have to still be aware that the animation here is potentially sending data to the parameter, the com channel 1 parameter, and modifying it. And of course that could mess up the commands that we're trying to send to our state machine behavior on our second zombie walk animation on the lower body layer. Now, it just so happens Unity's animation system is quite intelligent like this. So if the base layer has a walk animation that is animating, and at the same time the lower body layer also has a walk animation that is animating, and they both have curves defined that are supposed to be setting values for a parameter called com channel 1. Well, in our case, where we have all of our blending modes of our layers set to override, then Unity will correctly say, hey, don't worry about this walk animation on the base layer. Don't let that set the parameter. Instead, it will say let the curve on the higher layer, in the lower body layer, be the one that is setting the values of that COM1 channel. So that's exactly what we want. This wouldn't be the case, however, if we set this from blending to additive. We would get an add of whatever values the base layer is sending to it, plus whatever values the lower body layer is sending to it. So we've established then that as long as we have the blending mode of our layer set to override, which we have in all of our cases, then if we have an animation playing on the base layer, which has a COM channel 1 curve defined for it, and we also have an animation on a layer above it, sending values to the same parameter, well then the values of the curve on the higher layer are going to be used to control what value is currently in COM channel 1. That's exactly what we want. However, when there is no matching curve on the layer above it, the curve defined in the layer beneath it will be allowed to still come through and alter that parameter. So I'm trying to think of a good example. So let's imagine then that on our base layer, we have an idle animation that has the zombie shuffling left to right. And we might want to make some footstep sounds when it's shuffling left and right. But on the lower body layer, in its idle animation, it's a perfectly static pose. The zombie isn't shuffling about at all and shouldn't be making any footstep sounds. We might decide that for this animation, because it doesn't need to make any footsteps, there's no point making a COM channel 1 curve for it. However, because this animation doesn't have a COM channel curve defined for it, it won't override the COM channel 1 that might be on the zombie idle animation in the layer underneath it. And therefore, the curve defined in the layer underneath it, in the base layer in our example, would still be allowed to send its values to COM channel 1. Now, this may or may not be what you want, but it's just something you have to be aware of. It's not so much of a problem for us because none of our idle animations make footstep sounds, but it is important to realize that that can happen if you have one idle animation that doesn't make footstep sounds and one idle animation that does. Now, there's a few easy ways around this. The easiest way really is just to make sure that in the second idle animation, you just add an animation curve for COM channel 1 that's just a flat line of 0. And that way, the COM channel 1 curve in this animation, which is constantly 0, will be used to set the value of COM channel 1 instead of whatever curve is defined on this animation. We're also going to put other things in place that are going to make things a little bit easier. Our animation collection player script is also going to do things such as allow us to specify exclusion layers. So we'll be able to say, I don't care what your curve's saying, if we're on the base layer and you've been told to play a footstep sound, but the lower body layer is active, then just ignore any sound request on this layer. This layer is no longer in charge of generating footstep sounds, and that just gives us an extra layer of protection. We don't really need it in this particular case, but we might need it later on when we're maybe reusing COM channel 1 for our cinematic layer or for our hit layer. I don't know if I'm going to do that yet, but I'm just saying those are the things you need to be aware of. Okay, so we have a basic understanding now of how this is going to work, and we understand some of the dangers that are there. I'm going to have to write scripts now that manage those dangers adequately. So the first thing we're going to do is create an audio collection player state machine behavior script. So I'm going to go down into my scripts folder, into my AI folder, and I'm going to drill down into my state machine behaviors folder where we have 3 state machine behaviors already assigned: the cinematic enabler, the AI state machine link, and the root motion configurator. So the first thing I'm going to do is I'm going to open up my AI state machine link, which is the base class from which all of my state machine behaviors are derived. And I'm going to define an enumeration for each of those COM channels that we've just created. Let me just zoom in so we can see things a bit more clearly. So I'm going to create a public enum, and I'm going to call this COM channel name, and I want each member of this enumeration to match exactly the names of those parameters that we've added. So COM channel 1, COM channel 2, COM channel 3, and COM channel 4. And the reason I'm creating this enumeration is when we create our audio collection player state machine behavior in a moment, I can have a variable of this type in the script, and that will allow us in the inspector via a nice drop down to choose which COM channel we wish that script to be listening to for its commands. So I want COM channel 1, COM channel 2, COM channel 3, and COM channel 4. Okay, so now we've modified our AI state machine link script. I'm going to create a new C# script, which is going to be our audio collection player. And then I'm going to open it up in MonoDevelop. So first thing I'm going to do is get rid of the start and awake function, because actually this isn't going to be derived from mono behavior at all. This is going to be derived from our AI state machine link class. Okay, so let's create some inspector assigned variables first. The first thing I want to show up in the inspector is what command channel this instance of the audio collection player is supposed to be listening to. So I'm going to create a serialized field of type com channel name. Remember, com channel name is that enumeration that we've just created in our AI State Machine link class. And I'll call this variable command channel with an underscore, and by default I'll set it to com channel 1. I also need to be able to assign an audio collection to this script so it knows when it gets a command to play a sound which audio collection it should be using. So I'll create another serialized field of type audio collection. Remember, that's the scriptable object class we created in the last lesson. I'll call this collection and I'll set this to null by default. Now if I save that off now, go back to the editor, and on my base layer, I'm just going to select my idle state. In fact, I'm going to do all of my tests on the idle script, and in a moment what we'll do is we'll lock our character into idle, and when we're designing all of the curves for all of our animations, I'll temporarily just keep swapping the motion field into the idle state, because that means that as soon as I press play, I get to see exactly that animation playing, and I don't have to sort of wait for the zombie to go into a turn left, turn right, feeding state, whatever. So if I add now a behavior to my zombie idle state on the base layer, and I'm going to add audio collection player, you can now see, thanks to that enumeration, we've now got a nice little drop down where we can assign it one of our com channel parameters, and I'm going to leave this on com channel 1. And of course I also have a slot where I can assign a reference to a collection. So I want to assign this our zombie footsteps collection. Okay, so far so good. So let's go back to our audio collection player script and continue writing it. And I'm going to continue on now by defining some private variables that we're going to need. The first is going to be an integer, which I call previous command. Now each update, we're going to sample the value of com channel 1, or whatever com channel has been assigned to this script. We're then going to cast that to an integer. So for example, we'll have an integer called command that is 0 if there's no requests for anything to be played, a 1 if a request is being made to sample a sound from bank 1 of this audio collection, or a 2 if there's a request to sample from the second bank in the audio collection. However, often when we define an animation curve, it's much easier for us if we don't have to worry about just making the curve go to 1 or 2 for a single frame of the animation. It's nicer for us to draw the curves in bigger over longer periods of time so that they're easier to manage, they're easier to edit, and they're easier for us just to see them when we're looking at the curve in the animation importer. So what we don't want to do is this. Let's say, for example, I have an animation that just makes one footstep sound at 1 second. So on the animation curve, at a second into it, I would make the value of that curve go from 0 to 1. And I might make that curve stay at 1 for, let's say, another whole second before I set it down to 0 again. So when I look at the curve in the animation importer, I can clearly see, that's where a footstep is supposed to be played. However, during each update of our audio collection player script, when we're sampling the value, obviously that value is going to be 1 for like a second long in that example. And what we don't want at 30 frames per second of animation is to play 30 footstep sounds when really all this should have been is one footstep sound, but we're just making the curve last longer. So what I do in the update of this script is once I've got the command, just at the bottom of the update function, I store that command in the previous command. So in the next update, when I read the command again, I can see if the current command is different from what it was in the previous frame, because we only want to take any action if the command that we've sampled is not 0, and also if it's not the same as it was in the previous frame, because otherwise it's just a continuation of the curve from the previous command. So that's why we have this previous command integer. Next up, we're actually going to need a reference to the audio manager. So just for convenience, so I'm not always typing audio manager.instance, I'm going to cache this in the onStateEnter function in a minute as well. And finally, we need another variable of type integer, which I'm going to call command channel hash. Now, what we're going to do is in the onStateEnter function, we're going to examine what the value of our command channel is to find out which member of that enumeration we've assigned it to. We're going to use the toString function of command channel to get just this bit. So we're going to get either com channel 1, com channel 2, com channel 3, or com channel 4. Once we've got that string, we know that that should match exactly a parameter that is defined in our animator. But of course, we need to fetch the value of that every update to see what commands are coming in. And we've already discussed multiple times that it is inefficient to use string queries when querying parameters. So what we'll do is we'll generate a hash for that string once we've got it. Once again, we'll do that in the onStateEnter functions. So that's what the command channel hash is going to hold, just the integer hash of whatever COM channel we've assigned it to, which of course is also going to be the hash of a parameter in our animator. Okay, so let's write our first function, the onStateEnter function, which of course is called by Unity when this animation state is first entered. The first thing I'm going to do is I'm going to grab a reference to the Audio Manager instance, which should be in the scene. I'm also going to make sure initially that previous command is set to 0. And next up, I want to generate this command channel hash. So what I do is I say if command channel hash equals 0, which means it's the first time we've ever stepped into this function, then command channel hash equals, and of course we use that animator's static string to hash function, passing in what the value of our command channel enumeration is and using its toString function. Of course, what the toString function will do is it will just output as a string this final bit. So in the case of command channel 1, it won't output com channel name dot com channel 1. It will just output com channel 1, which is the exact name, or at least should be, of the parameter that has been defined in the animator that we're wanting to watch. So that is our onStateEnter function done. The only other function we need to implement here is the onStateUpdate function, which once again has exactly the same signature. So the first thing we're going to do is we're going to make sure, as a bit of protection, we're going to say if the layer weight of this layer is 0, then we just don't want to do anything. We're going to assume, like Unity's animator does, that if the layer weight is 0, then we don't want any sound requests to be processed and we just wish to return. Of course, the first layer doesn't have a layer weight that can be changed. It's kind of stuck. I think the default is it's just stuck to 1. So what I do is I say, if this isn't the first layer, in other words, our base layer, then let's get the layer weight and let's see if it equals 0. And if it does, just return from the function. There's nothing for us to do. Even if there is an animation playing and it's sending values to the curve, it's got a weight of 0 and we shouldn't process any sound requests. Next up, we'll just check we have a valid reference to the state machine. Remember, this is derived also from AI State Machine Link, and you will remember that AI State Machine Link contains a reference to the AI State Machine that this animator is being used for. So if we don't have a state machine, we're also going to return. So the next thing I want to do is fetch the value of the parameter that we're watching, one of our command channels, whatever the value of com channel is. So I use the animators.getFloat function, passing in our command channel hash. But notice that this returns a float, and what I do is I use the mathf floor to int function to make sure that I round it down as an integer. So if it was 0.9, for example, it would return 0. If it was 1, it would return 1, but if it was 1.5, it would still return 1. And this is how I like to work, because often when you're putting curves in the animator by hand using the curve editor, you often have slopes from sort of 0 to 1, and you don't want there to be any sort of ambiguity about where that command is actually processed, where, for example, if we round it in a different way, then at 0.6, that might be rounded up to a 1, and then our footstep would be playing earlier. So it doesn't matter anyway, because when we create our curves, we're always going to make sure that the values are 1, 2, or 0, sort of whole integer values. But it just means that if we have any slopes from 0 to 1, then that command won't be processed until it is actually 1 and not 0.9. So you can see here that once I've fetched the value of our com channel parameter and I've used the floor to int function, I now have an integer command. Now I need to see if this command is different from the previous command, because like I said just now, if it's not, then it's not a new request. It's just a continuation of the same curve from a previous request. So I say only if previous command doesn't equal the current command, and you'll see in a minute at the bottom of this function, we'll then assign command to previous command, so that in the next update, previous command will equal what this command was this update. And assuming that command is non-zero, remember 0 means nothing, and assuming we have an audio manager, and we have a valid reference to an audio collection, and we have a valid reference to a state machine, which actually isn't needed because I do that reference up here, but I guess that's some legacy code that got left over from a copy and paste. I'll take that out at the end. Well, then what we're going to do is we're going to use that command as the bank that we're going to use to sample an audio clip from our collection. Remember, I said the curve itself carries the bank command. So I create a local integer variable called bank. And what I really want to do is just use this as is as the bank request. But of course, I can't rely on the fact that the value in the curve isn't larger than the number of banks available in the collection. So as you can see, I use the mathfmin function to check that we don't overflow the bounds of the number of banks in the collection. So I say I want you to take the minimum value between the bank count -1, which is the last bank that we have, and also command -1. Now the reason I subtract 1 from command is because our banks in our audio collection are 0 index relative. So the first bank is bank 0, and the second bank is bank 1, and the third bank, bank 2, etc. But of course, in our animation curves, 0 doesn't mean play a sound from bank 0, it means play nothing, and 1 means play bank 0, and 2 means play bank 1. So that's why I subtract the 1, because our curve is always 1 higher than the bank it's actually describing. Okay, so now we know the bank in the audio collection we wish to use. We want to suck an audio clip out of that bank along with other information to do with the audio collection and send that into the audio manager's play one shot function. So I will say audio manager.play one shot sound, and the first parameter is what channel on the audio mixer, or audio group should I say, should this sound be played on. And of course the audio group is also a property of the audio collection. In the case of our zombie footsteps collection, we know it's been set to zombie, and in the case of our player collection, it's been set to player. So we're fetching all of this stuff from the collection and then just passing it through to the audio manager's play one shot sound function. As a second parameter, we need to actually pass the audio clip, and of course we can just say collection and then use that array syntax property that we set up in the last lesson, passing in the bank. And of course this little property call here will return a random audio clip from that bank. The third parameter is where we wish to play the sound in the scene, and of course that is going to be at the position of the state machine. And of course we also want to send in the spatial blend property of the collection as well. And finally we also want to send in the priority of this collection. Finally, at the end of the frame, we're going to store a command in previous command. For now, this script is done. I'm going to come back and add a few other things to this. I said a while ago that I wanted to add the ability to have exclusion layers, and we'll add that later, but we don't need it just now, so it's better to go in baby steps, I think. So let me go back now to Unity and just check I haven't got any errors. Okay, so before I carry on with this, there is actually one thing I want to address with my audio manager. I want to change one of the names of the functions that I set up, was it either last lesson or the lesson before. Let me open up my audio manager script. Now, I actually had some people on the GI website sort of saying that when they tried to use this script with a previous version of Unity, they were getting a error saying that there was an ambiguity because we had two functions here, play one shot sound that returns a U long, and the play one shot sound that returns an enumerator and has an additional float parameter. It's a dangerous thing that I've done here anyway, because the last parameters are default parameters. Okay, so if you were trying to call this IEnumerator version, right, and you decided not to specify the last parameter and just use the default, well then technically I'm not quite sure how it knows that that isn't this version of the function with you specifying that final parameter. But either way, I do not like it. It's dangerous. So what I'm actually going to do is I'm going to change the name of this function to something that I think is more descriptive anyway, and I'm going to call the coroutine version play one shot sound delayed. All right, so that should not cause any problems or cause any ambiguity either for the compiler or even just for us if we're reading this code. It's very obvious now. If we call that version, it's the one that should be used with a coroutine. Okay, so we have a single audio collection player assigned to our zombie idle 1 state. Like I said, this is the state we're going to use for testing all of our animations. So what we need to do now is actually create a curve on our animations to see if any of this stuff works. And what I'm going to do first of all is I'm going to set up the first walk animation on the base layer, which is this one here. It's called zombie walk childlike. Okay, it's this one here. So what I'm going to do to make things easier is I'm going to assign that to my idle state. Actually, before I do that, let me just remind myself what idle I use. I use Jill at zombie idle 1, just so I know how to put it back afterwards. Okay, so I'm going to select my walk state, and I'm going to drag and drop that animation into the motion field. Okay, so let me press play, and you'll see that in idle, we're forcing it to walk forward, even though it's not really using any locomotion state yet. And what I'm also going to do is I'm going to select Jill's AI entity, and I'm going to scroll down to her AI idle state, and I'm going to set her idle time to some stupid amount of time by putting, like, I don't know, 4 zeros on the end of the idle time range. And when I press play now, she will just stay in idle, but we're also going to be forcing her to walk. Now, of course, because we're doing this in idle, she's not doing any logic whatsoever. So what you'll see is her just walk into a wall here, and she'll just continuing to walk, because we're not doing any path finding or anything at this point. We're just sat in the idle state. Our state machine thinks that Jill is perfectly still at the moment, but we're just forcing her via root motion to walk forward. But what's really nice about this is when I add some curves to this animation, I don't have to worry about waiting for her to walk forward. I can just press play and instantly see what she's doing and see if the footsteps are in sync with the legs. And even better is I'm going to do this every time I work on an animation. So if next I work on the zombie run animation, I'll put that in the idle slot, press play again, and I instantly get to see Jill running or turning on the spot or feeding or whatever. So it's a big time saver. Okay, so the next thing I'm going to do is I'm going to select the zombie audio collection. What I'm going to do, just temporarily, is set the spatial blend from 1 down to 0. Remember, the audio listener is on our FPS controller rig, which at the start of the level is quite some way from Jill. So I don't want to have to press play and walk over to Jill every time just so I can hear her footsteps, because they're being attenuated with distance. Instead, I just want to watch things from the scene view and always hear her footsteps, so I can just not care where the audio listener is in the scene. It's going to be a 2D sound and I'm going to hear it. Okay, so let's now select that very first animation, Zombie Walk Childlike, which is in the Game Institute Locomotion folder, and let's go and add a curve to this animation that is going to send some values to the COM channel 1 parameter. So let me arrange my workspace a little here so I can see what I'm doing. And I'm going to open up the curves drop down. I'm going to add a new curve, and this curve is going to be called, you've guessed it, COM channel 1. And now what we need to do is, oh God, I've just realized I've got a lot of points to add to this animation. It's massive. There's loads of footsteps in it. Oh, jeez. Okay, well, let's just crack on with it then. Okay, so the first footstep is about there, right? So I'm going to add that there. I'm going to spool on 1 frame. Oh, I've just added another curve. Didn't mean to do that. I meant to add another keyframe. And then we'll put it down to 0 about there. 0 about there. The shape that I'm trying to make here, I mean, you should remember this from when I did the curves last time. I'm just trying to kind of create a thing that looks like that hill from Close Encounters of the Third Kind. Okay, so that's our first footstep, right? That's her right foot as you look. It's probably a little bit out, that one. I might have to come back and change that later. Okay, so there's the next footstep there. So remember, we create sort of 2 next to each other. So we don't have like really long slopes, although that doesn't really matter too much. Now I've put that previous command and that floor to int snap in my code. But even so, it still makes it kind of easier to see what's going on. Okay, now with that one there again now. Add keyframe, put a 1 in there. Move on to right there. Move on a little bit. Another keyframe, set 0 down to there. Ah! God, I find this interface a bit painful at times. Just sort of clicking out of it. Okay. Okay, so there's the next one is there. Once again, add a keyframe, wait till your legs about halfway across, add a keyframe, and I'll go back and put those in so that the inner keyframes are at 1, like so. I just noticed, look, I've just lost the name of the curve as well. So stupid, this interface. It does that sometimes if you don't press enter. Don't like that at all. Okay, put 1 in again there, and then we'll roll on again and put a little 0 in there. The nice thing about this walking animation though, another one there, is that because there's lots of footsteps, it sort of changes speed quite a bit, so you don't get a kind of clip clopping when the sounds play that make them all sort of sound the same, you know, and that's what's really cool about it, that the speed actually of this animation changes within the animation itself, and I do quite like that, I've got to be honest. God, almost there. Okay, and you can see I'm just waiting to see when the foot hits the floor. Putting the one in, scroll it across a little bit until the other foot is sort of midway in the air. I mean, it could just go up for one frame, but I just like making these longer humps so that I can see it easier just by looking at it with my eyes. Well, let's face it, what else would I look at it with? Look at it with my toes, am I? Dear me. That's how I know I'm stressed doing things like this. I get stressed when things are boring, not when things are like exciting or when things are like worrying. It's like when I'm worried, I'm fine. I get really stressed when I'm just really worried about how bored I'm going to be putting in these curves. Oh dear. Yeah. Another one there. Actually, I'll probably wind that back a little bit. I'm going to show myself doing all of this. I mean, I could just run this on, but I want to do a few of them where you see me actually doing it all from scratch, and this is quite a good one, to be fair, isn't it? Because there's a lot of curves on it. So there you go, add keyframe, spool on twice on the right cursor key, add another keyframe, run it on till the other leg, the opposite leg, is about midway. That's how I like to do it. So that's a 1, that's where we're going to start to bring the curve down. To 0. I still think that very first footstep might be a little bit out. See, that one's quite close together there, isn't it? So about there. Yeah. I'm not just going to talk for the sake of it, guys, right? Because I'm sure you're all sick to death of my voice by now. So I'm only going to say something here when there's something worth saying. Except for what I just said, which wasn't really worth saying. Okay, so I need to find out what's happening at the end here. So another footstep at the end here. It's right on the edge. Yeah, it goes down. That's where the loop is, isn't it? So I think what I'll do is I'll just open up that in the curve editor a minute. I think I will drag that first footstep a little bit closer. And I'll also right click on it and do edit key. That way I can make sure, because when I moved it then I kind of dragged it into negative values. So you can drag it over to right there. Then you can do edit key. And then you can set the actual value. So that one I want to be snapped to 1. And there is our curve. So let's once again rename it COM Channel 1. I'll tell you what, if something happened now and I lost this before I had a chance to apply changes, I'm pretty sure I'd give up computer game development for the rest of my life, because I'm not going through this crap again. Okay, I'm applying the changes. Oh, thank God it's saved. Okay, so shall we see what happens, if anything? Let's be honest, I expected more. What's going on? Okay, let me just call up the animator, look at the parameters, and see if we're at least feeding the parameter correctly. We are. Okay, so we're feeding, you can see the footsteps are happening, but for some reason our script is doing absolutely nothing with that data, which is, I'll be honest, unexpected. So I think what I'm going to do is I'm just going to make sure that my audio mixer isn't getting any registration of sounds and I'm just not hearing it. No, that puppy is really not making sounds, is it? Okay, let me go back to my state machine behavior, which was called audio collection player. Yeah, I did save it. That's what I was frightened of. Jesus. Okay. I'm going to have to pause the video and figure out what the hell I've done wrong here. I'm back, folks, and thankfully the reason why this isn't working is a very silly mistake. Look at my audio mixer and look what my zombies group is called. It is called Zombies. And to what group did I assign my Zombies Footsteps collection? To Zombie without the S. What a pillock. Okay, so that's all that was needed. I just spelt it wrong. Let's press play, call up the scene view, and see what happens. See if she's in sync. I think we can call that a success. I mean, obviously the footsteps are really in your face at the moment. They're not being attenuated because they're a 3D sound. But if I go now to my footsteps and set the audio collection spatial blend back up to 1, and then press play and actually go and see Jill, you can hear her footsteps in the distance, and they sound quite convincing though. Okay, cool, that works. I'm pretty happy about that, because when I pressed play and there was no sound, I didn't have the faintest clue why that wasn't working. So end of Dead Earth. Okay, guys, we need to go on now and do some of the other animations, like the run, the sprint, and the turn left and turn right on spot. I'm going to do a few of them in real time, like I did just now, but I'm not going to do probably all of them, because you're just going to be watching me doing this for half an hour, and I think that would literally bore the shit out of you, wouldn't it? Okay, so let's call up Zombie Jill's AI entity, look at her animator, and this time look at zombie jargon. Let's see what motion field she's using. Oh, look at that. There's only 2 footsteps in that one. That's my type of animation. Those are the boys I like to back. Okay, so it is called Zombie Run. Let me call it the project view and click on a motion field so I can see where it is. There it is. And now what I'm going to do is I'm going to select Jill's idle state, and now I'm going to drag the Zombie Run motion field over and store that in our idle state as well. So of course when I press play now, you'll see Jill run immediately, and we won't hear any footsteps either, because that animation doesn't have the COM channel 1 curve on it yet. So let me select Zombie Run, which, just for your reference, is in my Game Institute Mixamo animations folder, and it's called Jill at Zombie Run. And I'm going to try and do this curve in much slicker fashion. So I'm going to open up the curves drop down, I'm going to click the plus sign, I'm going to call this COM channel 1, and I'm not going to let it confuse me this time. I'm going to press enter straight away, and I'm going to just open up the preview window so I can see what I'm doing a little bit better, and I'm going to just spool through it until I see that first left foot hit the ground, which is probably about there. Add a keyframe, tap the right cursor key twice. Actually, that's too many. Why has that gone on so far? What's going on here? Okay, maybe I'll just go forward by dragging it with the mouse, because that can be a little bit finer. I don't want to have a big slope between the keys. So we'll do it to about there. And this is where I'm going to turn that command off. And then I'm going to scroll down until the next foot hits the ground, about there. Add a keyframe. Drag it a little bit further, add another keyframe, and then till about there, I guess, and turn it off by adding another 2 keyframes. And then what I can do is I can just use the rewind and forward wind to kind of step through the keyframes. So that one needs to be 1, and the next one needs to be 1. So there's my first little hump, and then we'll spool onto the 2 inner keyframes that I created at the end of the animation. Things are going to get a lot quicker from now on, because that first animation with all of those footsteps, that's not typical at all, I don't believe. Mostly we're going to just be adding like 2 curves. So all I've done now is added COM channel 1 curve to that running animation. Let's just press play now, and I believe that should just work right out of the box straight away without us doing anything else. It's awesome, isn't it? Just awesome. But what I need to do, I think, is while I'm testing this, is put my sound back down to 2D sound for my collection. Let me say that again in a way that even remotely made some kind of sense. What I need to do is go into my sounds folder, my audio collections folder, select zombie footsteps, and move that spatial blend slider all the way down to 0, so it's nice and loud and in my face while I'm testing. Yeah, I think that qualifies. Actually, I think I'm going to move the spatial blend up to about halfway because that really is too loud. Yeah, that's better. Okay, so that is the curve for the jog state done. I'm not quite sure what I used on the sprint. So the sprint animation that I used is actually in the game, is in the Animations Unity Technologies folder, and it's called Default Avatar at Run Forward Neutral Face Forward. I think that stands for neutral. So let's select that. Just have a look at it. Once again, not too many to add there, because it's quite a short animation. What have we got? It kind of starts with its foot on the floor, so I'll make the sound up as soon as the animation starts. That'll be with the first keyframe. 2. Actually, no, I think I'll... Yeah, it's a bit weird because it rolls over at the end. I think I'll put it right at the start, actually, there. So from the curves drop down, I'm going to create a curve. I'm going to call this COM channel 1, obviously, like so. And right at the start of the animation, I'm torn whether to put it at the start or the end. Kind of, it's more like there, isn't it? Yeah, it's more like there. So I won't put it at the start of the animation. I will put the first one when the left foot hits the ground, about there. Add those that 4 keyframe pattern around about that area that you know I like to use. And then I think the next one's about there, isn't it? Is it about there? A little bit more. Right there. There. And I can fit in the off command just before the end, can't I? There you go. So let's put all the ones in now, where the actual triggers are going to happen. So in case you didn't realize what I was saying earlier when we were talking about previous command and next command, if you imagine this animation is playing, right, look at the cursor up here in the curve, right? So we're getting a command of 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, right? And that's where we play the footstep sound. The next frame, we're there. We're still getting a 1, but we don't want to play another footstep sound, right? So that's why we say once it's a 1, we never play another footstep again until it changes to something else, either a 0 or 2, and then back to a 1 again. That's fine. But once it's 1, while it stays there, we don't trigger any more sounds. So I'm going to apply that. And then what I'm going to do is I'm going to select Jill's idle state again. And this time I'm going to replace her idle state with that run animation that we just created. This is a pretty fast animation, so it's going to be over pretty quick, I would have thought. It'd be helpful if I had the scene view up, wouldn't it? Okay, let's try that. Come on, Jill. Come for us, baby. Yeah, there you go. So we've already done now all of the footsteps for all of our walking. So what we need to do now, or at least on the base layer, what we need to do now is we need to do the zombie turn left and zombie turn right. Now, are these 2 separate animations? Did I just mirror them? No, they're 2 separate animations, which I thought was clever at the time, but when it comes to putting curves on things, I kind of wish I mirrored them. But I will put them, I'll do them as 2 separate curves. Why the heck not? So let's have a look at Zombie Turn Left, which is in the Animations, Mixamo Animations folder. It's Jill at Zombie Turn. And this is the single animation that we defined 2 animations from. Remember, Zombie Turn Right, Zombie Turn Left. So let's add some curves here. 1, 2. Yeah, it's just 2 on each one, so that's not the end of the world, is it? I think we can cope with that. So I'm going to add a curve. And at the moment, what animation have I got selected? I've got Zombie Turn Right selected, okay? I'm going to call this COM channel 1. Just make sure I press enter there. And we want to do the first footstep about there. Yeah, about there. Once again, we add those 4 keyframes in that familiar pattern now. And we want to put the next one to be triggered about there, doesn't it? Not always easy on the grid to see exactly where you think the foot is hitting the ground, but that looks about right to me. And then I'll just go back over those inner keyframes of each group of 4 and make sure that they're set to 1. Like so. So let me just spool along and see if that looks about right to me. That one definitely looks right. Yeah, I think that looks about right. So we'll apply that, and then we'll select zombie turn left and add kind of a similar curve to that one as well. It'll be slightly different, obviously, because it's rotating in the other direction. So once again, we give it the name Com Channel 1. Yeah, first one's about there. Turn it off about there. It's got plenty of time to get ready for the next footstep, which is about there. Not being that precise, am I? But to be honest, you don't really need to be. You'll be absolutely staring at the zombie's feet when it's running at you. You'll be too busy trying not to get your face chewed off. Let's click apply. And did I do that on both of them? I did, didn't I? I've done both, haven't I? Yeah. I just suddenly thought I'd forgot to press apply changes to the first one. Okay, so we're going to select idle now in Jill's animator, and this time we're going to drag over zombie turn left as the idle motion field, and then we'll go and have a look what zombie Jill looks like. One of those seems a bit late, doesn't it? It's the second one on zombie turn left. It's a little bit too late when you see it. So zombie turn left. Didn't quite get that right, did I? Yes, that next foot needs to go down a bit earlier. Yeah, it needs to go down about there, doesn't it? So, yeah. What is that? 0.6. So I need to move that back to about there. Once again, I'll edit key and make sure this is all definitely 0. And I'll move that one back to 0.6, which is what I think it should have been made. Once again, remembering to edit key, so it's definitely 1. Remember, with that floor to int function we used, if that was moved slightly, so it was 0.99, it wouldn't be rounded up to a 1. You wouldn't get a footstep there. So it's very important we make sure that these things are definitely at 1. Okay, let's see if that looks a bit better. Much better. Okay, so let's now plug in to that idle state the zombie turn right. See if I got them in the right place there. Yeah, that one looks good. So there you go. We've now done all of the animations for our basic locomotion on the base layer. We've got idle, turn left, turn right, zombie sprint, zombie jog, zombie walk. Not bad. I'm not going to worry about doing the slow crawl and the crawl fast and the left and right swipe and biting at the moment. I'm going to actually carry on doing the footstep sounds for the time being, whereas these are slightly different. So what I want to do actually is I want to move on to the lower body layer, because that's going to allow us to, for example, put the cursor in this animation that does a dragging sound, which is pretty cool. And then we'll have all of the footsteps done, and then we'll start concentrating probably in the next lesson on adding attacks and things like that to the attack layer and the interactive layer. Now we've got all of the stuff out of the way. What I do want to do in this lesson though is I want to add the functionality to our audio collection player that allows us to tell it to not play its sound if certain layers are active. So I want to kind of get onto that as quickly as I can, because there's a little bit of code that needs to be sort of written for that. Okay, so with the first layer animation done, what I want to do really is I want to restore my idle animation. And then what we'll do is start working on the next layer down. There it is. It was zombie idle 1, wasn't it? Okay, so what I want to do now is have the animations on the lower body layer be played instead. So I'm going to start Jill off with some lower body damage. So that layer immediately has its weight set up to 1. So I will put Jill's lower body damage up to about 40%. What was the lower body threshold? The limp threshold is 30. Yeah, so 40 should be fine. And yeah, let me just press play and check that is definitely the case. Yeah, the lower body now has a weight of 1 and is overriding the animations of the legs on the base layer. Actually, I've changed my mind. I'm not going to work on the lower body layer. I'm going to work on the lower body layer animations with respect to adding their curves. But I think I'm still just going to drag them into the idle state on the base layer to test them. That way I only have to remember to restore one state's animation once I'm done with it. So I'm going to select Zombie Jill's AI entity and I'm going to undo that lower body damage that I just gave her. Let's put that back down to 0 again. Okay, so I think just because it's fun, the next animation I'm going to work on is the zombie jog that is being used on the lower body layer. I actually use the same animation for zombie jog and zombie sprint on the lower body layer. It's just on the zombie sprint, I speed up the motion field by 1.75, whereas it's just 1.25 on the standard jog. And with the walk, I think that's just another sort of standard using standard footsteps. So that's nothing really any different from what we've done already. So this one will be more fun because it will allow us to use the second bank. Oops, I've closed down the preview window. This is called Zombie Injured 5. So that's this one here. It's in the Animations Game Institute damage folder. The actual animation clip itself is called 105_25. So let me now select my base layer, select my idle state, and let's drag that field now over into our idle state on the base layer. And when I press play now, we should see our zombie immediately start to limp. There you go. Much better way, isn't it, of testing stuff. Just doing it like that. Then we don't have to wait for it to naturally transition into anything. Okay, so let's now select that animation. I'm going to make the preview window a little bit bigger so I can see what I'm working with. And I'm going to scroll down. I'm going to open up the curves drop down. I'm going to add a curve, and of course the name of that curve is going to be COM Channel 1, our footsteps channel. And I'm going to spool forward to where the first foot hits the ground, which is about there. Add a keyframe, run it on a little bit, add another keyframe, run it on a little bit, add another keyframe, and another keyframe, and then almost immediately we're going to start dragging about there. So I'm going to add another keyframe there, another keyframe there. Doesn't really matter how big that is, but I'll make it quite a big curve just so I can see visually when I look at the curve that that's probably a drag sound that we want to play there. But like I said, our script doesn't really care about how long the curve is set to 1 or to 2 because it only plays the sound when it first changes the command. Okay, so obviously this first command is just going to be a standard one which we've used all the time, but then this second one we're going to put a 2 in there, okay, and that's going to tell our script to choose a random clip from the second bank, which is the bank that contains the dragging sounds. So if I click apply now and press play, look in the scene view. That is very cool, is it not? And of course that will also work on our lower body layer for the sprint state as well, because the sprint state is using the same field, so therefore it's got the same curve on it. So let's do the zombie walk now for our lower body layer, which is Zombie Walk Injured 2. It's in the same folder, right? So it's in the Animations Game Institute damage folder. So let's add a curve to this puppy now. Actually, first of all, what I'll do is I will select my base layer, I'll select my idle state, and then I will drag that motion field over from Zombie Walk Injured 2, which is the actual animation is called 91_24. Really helpful names, aren't they, these? And we'll go and add some curves to that. This one's not using bank 2, it's just using bank 1, so this is just similar stuff to what we've done many times before at this point. So I'll assign it COM Channel 1, but I'll spell it correctly because I think that would be helpful. And then I will... Where's that footstep? Where's that first step? So I think right at the beginning I will add a keyframe there. That's for that first step. And I'll turn it off about there. And then I'll run on to where I think the second footstep should happen, about there. Not very good animation, this. This was from that mocap library, but I think it didn't really come into Unity that well. I think the feet are crisscrossing and stuff, and doesn't look too good if you really study it in the game. But really it's just for me demonstrating to you how to use these curves and these animations, how to use different animations with different controllers, because I really am assuming that you guys are going to go on the asset store and either buy some much better animations or maybe make some of your own if you guys are animators too. Okay, let's go on to the next one. This one's got quite a lot of footsteps in it. Damn, these walking ones, they're a real pain, aren't they? Quite a big gap, isn't there, between that and I can end it. See, really, that footstep shouldn't be at the beginning. It should be about there. Will I get away with letting it roll over? I think so. So, because I've put the footstep right at the very start, so it's going to be that very first step might be a little bit late, but I think I'm going to go with it. So we'll turn off that last one about there, like so, and then we'll go through them all and add all the ones where we need them. Okay, so talk amongst yourselves while I'm doing this. That seems a really long footstep, that one, doesn't it? Have I gone wrong here somewhere? I think I may have gone wrong here somewhere, and I've got my inners and outers mixed up. No, I don't think I have I? So, yeah, haven't I? I've got it wrong. That one. That footstep happens there. That footstep happens there. There's not a footstep there, is there? Yeah, I've got these are all wrong somehow. Okay, there's like a really big gap where no footsteps are being made at all. I guess it's a very slow stride, that one. So let me just put those down to 0 again so I can figure out what a mess I've made of this. Okay, so foot goes down, yeah, 1, that one stays like that, and then the next one doesn't need to go down until there. Okay. So that's where the next one is. So I've got a few keys now I don't really need. I don't think it's going to absolutely kill us, is it? So let's delete that one. Can I delete these? I probably have to delete them in here, don't I? So I'll delete those 2 unneeded keys in there, like so. And that's it. So I'll apply those changes. And I think I already assigned it, didn't I? Yeah, to the idle state on the base layer. So let's press play now and see if that one works. That works fine. So at the moment we're flying, right? Oh, just do bear in mind that at the moment I'm just authoring the curves for the animations. We're going to have to come back in a minute and make sure that the audio collection player script is assigned to all of these states, which I haven't done yet. I've just got it on the idle state because that's the only one I'm testing. Ironically, it's actually the idle state in both the base layer and the lower body layer that won't actually need an audio collection player on it, because none of my idle animations actually have footsteps in them. But okay, so that one's fine. But now we're going to come into some problems, because on our lower body layer, and in fact on the lower body layer of all of our zombies, we use this kind of really labored turning animation, right? So we look at that and we go, hey, that's no problem. We can play the footsteps there. But look what happens when I select the animation and double click on it to bring up its importer. I don't have an option to add curves. And the reason for that is because these animations are older animations that I got from Mixamo. I think Mixamo thought they were being helpful, but what they did, and I think I've had this since like Unity 3, they decided to pre-bake the animations so that you didn't get them as an FBX and you didn't have to set up your own importation settings. They just gave them to you as, look, a .anim file, which is kind of what we get when we take one of ours and make our own animation from it. You know, we create anims from the FBX, but we add the curves on the FBX importer. So I've got quite a few clips here. I think I used about 4 animations throughout all of my zombies that are in this baked anim format, and it's really limiting. You just can't alter anything. You can't add curves to it. So it seems like we're stuck, right? There's no way for us now to use these animations. And it's even worse in our case because this animation we actually use a lot. It is pretty much the damaged turn on spot animation that we use for all of our zombie controllers. So what we're going to have to do is when we come across animations in this baked format and we still want to use them, we're going to have to find some alternative way of providing a curve to our script. Now, one way that we could do this is we could open up our audio collection player, right? And if I zoom in a little bit, at the top, I could create another serialized field of type animation curve and call this custom curve. And we'll set it to null. When I save that off, go back to the editor and now look at the inspector of our audio collection player, we now have the ability to define our own curve. All right, now this is kind of quite cool, but it's a real pain having to kind of select our animation. And we can't have the curve editor window open at the same time. We've got this open. You'll see what I mean. If I sort of go back to our audio collection player, open up that, the minute I click anywhere else in Unity, I lose that window. So what we have to do then is we have to say, right, we're going to need a kind of pen and paper, or at least commit to memory whereabouts within the 0 to 1 range each of these footsteps happen. And it's not really a problem. If we look at the very bottom of the animation preview window, you'll see in the brackets you have the kind of normalized time as a percentage. So we can see in the 0 to 1 range, if we were adding a keyframe in an animation curve, the first footstep would be around about 0.42 and the next one would be around 0.76, but it is a real pain having to go in and do that. Now, the problem is with making the animation curve like we've done here a member of the audio collection, that means that we're going to have to go in and painstakingly, wherever we use an animation such as this, which in the case of this damaged turn animation is pretty much the turn left and turn right states in all of our animator controllers, and we're going to have to manually put in all the keyframes, the ons and the offs and the ons and the offs, and it's really painful and takes a long time. And then of course if we decide that we want to put that animation somewhere else, we'll have to then define the curve then as well. Now obviously this curve also isn't being used at the moment. We're going to have to add code that basically says if this custom curve is non-null, then we're going to sample that using the normalized time of the animation state that's currently playing, and if it's null, then we're just going to use the value of the parameter that's being driven by the animator curve. So we can just say if the custom curve isn't assigned anything, then we're not going to use it, but if it is assigned, we'll use it. But a much better way of doing this, which means we only really get to define the curve once and then we can reuse it on any animation state that uses that animation, is we make our own custom curve wrapped in a scriptable object so that we have an asset in our project that basically just contains an animation curve, and then we can just assign that scriptable object wherever we use this animation. So that's exactly what we're going to do. So first of all, I'm going to go to my audio collection player class and I'm going to delete that animation curve. I don't want that. It's too hard to maintain. Just save that off and go back and check that it's no longer in the inspector. Then I'm going to go into my scripts folder and I'm going to drill down into my scriptable objects folder and I'm going to create a new C# script and I'm going to call this custom curve. And the great thing about obviously scriptable objects is I can then create multiple instances of this. So I can create a custom curve for each animation that I have that is pre-baked and doesn't allow me to add curves to it. So let me open up custom curve in MonoDevelop, get rid of start and update, because this isn't going to be derived from MonoBehavior. It's actually going to be derived from scriptable object, like so. And this is going to have a single serialized field, which is going to be an animation curve. And we'll call the variable curve. And what we'll do, just so the curve doesn't start empty, because that can be a pain, then you have to sort of start adding the keyframes. It's much easier if there are already some keyframes in it, is we'll just add a keyframe at 0 and a keyframe at 1. So we've got basically a 0 curve that is 0 to 1 in length. And it's very easy for us just to click anywhere along that line and insert additional keyframes. So we've got a scriptable object now that has an animation curve contained in it. And all we need to do is create an evaluate function that's really just going to evaluate the internal curve and return the result. So I'm going to create a public function called evaluate that takes a t value that's a float and returns a float. And of course, with that t value, we're simply just going to use the animation curve exactly as we would have used it if we were just using the animation curve class directly in the script. We just say curve.evaluate, we pass in the t value, and then we return the value of the curve's evaluation function. So all we have to do now is, instead of have a custom curve set up in our audio collection player, is we just have a reference to a custom curve, and then we call the custom curve's evaluate function just as if we were using the animation curve itself. But that curve is a project asset, and we can just reassign it and reuse it wherever we want. And finally, just above the class, we're going to add the create asset menu attribute so that we have an option on the asset menu to create instances of custom curves. And I'm going to call this custom animation curve. That's what's going to show up on our asset menu. So let me save that off, go back to Unity. And if I go to the asset menu now and the create sub menu, just as we have an option to create an audio collection, we now have an option to create a custom curve. So I'm going to create a child folder of my Dead Earth folder. I'm just going to call this custom animation curves. Then I'm going to drill down into there, go to my asset menu, go to the create sub menu, choose to create a custom curve. And I'm going to call this custom curve, actually, what was that animation called? Oh, the Romero turn on spot left. So I'll just say Romero turn on spot, like so. I don't think I need a left and a right. I think this time I am going to mirror it. So now when I select that custom curve, which remember is now a project asset, I can then go in and easily assign some keys to it. So it's still horrible building curves like this because we can't have the curve window open and the animation preview window open at the same time. But what I can at least do is, make notes of what it's supposed to be. Now, in my original animation controller here, you can see that I have a turn on spot left and a turn on spot right. I think what I'm going to do is just use the turn on spot left, add the curve to it, and then in the turn on spot right state, I'm going to assign it the turn on spot left again, but this time I'm going to mirror the state. That's what I'm going to do. And I think that should work. I think that means the curves should work fine in that sense. It means I only need one turn on spot curve. I don't need to create a right curve and a left curve. Okay, so let me select turn on spot left in my project view and assign that to the idle state on my base layer. There you go, turn on spot left, so that when I press play now in the scene view, we see that animation play out. Okay, so now I want to select that animation. I want to make a note of where the feet hit the ground, okay? So the first one should be at 0.4, and the second one should be at about 0.75. So 0.4, 0.75. I think I can remember that. 0.4, 0.75. So now I'm going to select my Romero turn on spot curve asset, and I'm going to add a key around about there, and I'm going to set, by editing the key, the time to 0.4. Actually, I'm going to set that to 0.39 because this is before it goes up to the 1. And I'm going to create another one there called add key, edit it. I'm going to set that one to 0.4, and I'm going to set that one to a value of 1. I'm going to close down the curve window for a moment so that when I reopen it, it sort of rescales itself so it all fits in the screen. So we need to turn off this command as well. So I'll edit the key. I will set that one down to, no, I'll set that one to 1. I'll also need to flatten the handles on that as well to flat, is it? Yeah. And then finally, I'll put another key in there. I'll set that to flat. Actually, no, I don't. Do I want to set that to flat? Oh, I don't think I do, actually. I just want to set the value of that down to 0, like so. I could probably move that along a bit like that. Edit the key again, making sure the value is still 0. And I'm going to put the next one at about 0.74. So 0.74 with a value of 0. I'm going to put another one in there. This is the one that actually goes to 1. We're going to set that to 1. We're going to set the actual time to 0.75. We're going to put another one in there. Edit key. Once again, this needs to be 1. I can leave it where it is with respect to where it is along the graph, because this is just the bit that turns it off. And I need to go flat there. And then I'm going to put one more key in at the end. Edit that key and set it down to 0. And it looks like I'm going to have to, do I need to flatten that? Yeah. And then we'll bring that over and just check that it's still 0 as a value. Okay, so I've created that as an asset now, and if I'm not mistaken, that curve should be perfectly in synchronization with this animation here that we're playing on the base layer. Problem is, obviously, we haven't added the code yet that uses the custom curve, so we're going to have to add some code to our audio collection script. So I'm going to go back to my audio collection script in MonoDevelop. There it is, my audio collection player. And now I'm going to create a new serialized field that is going to be of type custom curve. That's my scriptable object, and I'm going to call this custom curve. And we'll set this to null by default. And we know in our update function that if this is null, then we haven't assigned a custom curve, and we should just sample the actual curve that's on the animation, or in other words, read the actual parameter with the COM channel 1 name. But we know that if custom curve has been assigned, then we need to read that instead. So how are we going to do that? Well, we're going to scroll down to our onStateUpdated function, and just above where I declare that command integer, we're going to put a new line of code in there. So we're going to create a new integer local variable called custom command. So just like we use the mathf floor to int to get the value of our command channel parameter into a local variable called command, we're going to do a similar thing to sample that custom curve so that we have custom command, and then we can, you'll see how we're going to change the code in a minute to select which one to use. So what we're going to do with our custom command is we're going to say we want to set this equal to, and we're going to say if custom curve is null, then we'll just set custom command to 0. But if custom command isn't null, then we're going to use the mathf floor to int function, just like we do below, to snap it down to the closest integer. And then we're going to use our custom curves evaluate function. Now we need to send the t value into this, which is essentially the time that the animation is currently at along the curve. Now we have this information to hand because the onStateUpdate function passes us in this structure called the animator state info structure. And what's really cool about this is it contains the normalized time, so in the 0 to 1 range. And the way that we get this normalized time, it's kind of weird. It's like the integer portion of this value contains how many times the animation is looped, which we're not really interested in. We're just interested in the bit after the decimal point, which is the current normalized time in the 0 to 1 range. So what we need to do is we need to snap off the integer bit so that we're just sending in the the decimal bit. So the normalized time is stored in the normalized time property of the animator state info object that we've been passed. Like I said, this is in a format where on the left-hand side of the decimal point, we have a loop count. And on the right-hand side of the decimal point, we have the actual normalized time that we're interested in. And the way that we get rid of the integer bit is just to subtract from normalized time cast to a long. Okay, so we're snapping away the integer portion. We're just left with the floating point portion, which is the actual time within this iteration of the loop, and that's what we're interested in, and we send that directly into our custom curves evaluate function as the t value. So now what we want to do is we want to change this line of code here where we originally just got the value of our COM channel 1 and assigned it to the command, and we want to do a conditional here. We want to say if custom command doesn't equal 0, then command equals custom command. else command equals, then we do what we did before, just sampling the value of our com channel variable. And now the rest of the code works as it did before. So just to reiterate, we have a custom curve up here that we may or may not have assigned. And if we have assigned it, then you can see in this line, custom command gets assigned a value that is sampled from the curve. But if it hasn't been assigned, we just assign it a value of 0. And then down here, where we actually calculate what the actual command is that we're going to use, we say if custom command isn't 0, then it means we have been assigned a custom curve. Then that's custom command is going to be assigned to our command. Otherwise, our command is going to be what it was before, just assigned the reading from our command channel parameter. And like I said, everything else now works as it did before. So if I save that off now and make sure that I assign our custom curve now to our idle state in the animator, which is, remember, currently the state that is playing this turn on spot animation, we should hopefully see something in sync. And just to check that it's definitely going to work when we use it for real on the lower body layer, what I'll do is I'll mirror that and just check that if I mirror the state, the sound's still in the same places and it still hooks up with the feet. Ah, there you go, it doesn't. Okay, so we are going to have to use the two separate animations, turn on spot left, turn on spot right, and also have two custom curves, one for each. So the curve that we currently have then is to be used for the Romero turn on spot left. So I'm going to rename that. And then what I'm going to do is I think I'm going to duplicate it, because it'll probably be easier just to move the keys than it will to reinsert them from scratch. And I'll call this one turn on spot right. And then what I'll do is in Gears Animator, I will draw down into the lower body layer, call up the turn on spot right animation, and then we'll just spool through it and make a note of where the feet are supposed to hit the ground. So this time it's 0.5 and 0.8. So I'm going to select my custom animation curve, this time turn on spot right, and I'm going to open it up and I'm going to edit these things because they need to be moved forward a little bit. So I'll just drag them to begin with. I know really it's this one at the top needs to be 0.5, so that's the important one. Everything else isn't really that important. I'm just going to move them roughly into place, and then I'm going to go back, edit the keys, and make sure they all are correctly set to 0 and 1. And this one is supposed to be 0.8, isn't it there? Okay, something like that. Okie dokie. Okay, so now I'm going to edit these top keys. Make sure the values are definitely 1, because when you drag it horizontally, you can kind of drag it. There you go, like I have there, just dragged it slightly over 1, which doesn't matter. It's more a problem if you drag it slightly under 1, because we're using that floor to int function to sort of always round it down. And I'll edit these bottom keys as well and just make sure they are all definitely snapped to the value of 0, because I was sloppily dragging them around. Okie dokie, so we now have our Romero turn on spot right, and then what I'll do is I'll undo that mirror that I had in my idle state on the base layer, because if you remember I was using the turn on spot left field and mirroring it. So let's, for real this time, use the proper animation, which is the Romero turn on spot right, and also make sure that we assign it the Romero turn on right curve. Romero turn on spot right curve. So when I press play now, it should be turning right and it should be in sync. I think if I had to be a little bit fussy, I would say the very first footstep on that curve is a little bit late. So I'm just going to drag it forward to about 0.48 or something like that. Yeah, 0.48 I think I'll drag it to. Or 8. Okay, and see if that's a little bit better. The second footstep was fine, it was just the first one was a bit late. Yeah, that's right. So we've now got the Romero turn on spot left and the Romero turn on spot right curves Like I said, we haven't actually added any of the audio collection scripts to any of the states that need them yet. We're just still in the phase of authoring the curves, and that's why I'm just using this single state idle on the base layer just to test them. So at the moment, we're just working on the footstep animations. We're making sure that all of the locomotion animations that we're going to use throughout all of our zombie controllers do have these curves either defined for the animations, or we create a custom curve for any of those animations that are in a pre-baked format. So we've pretty much covered all of the animations that are in use by the first controller that we're going to be using. But of course, there are some other locomotion animations in some of those other controllers. Remember, I changed the motion fields over to use different animations. Some of those are going to need curves defined for them as well. And one or two of them are also very much like our zombie turn on spot left and right on the lower body layer of Jill. They are pre-baked animations that we're going to have to create custom curves for. So I'm going to do all of that offline so that when I come back at the beginning of the next lesson, I can show you some of the curves that I added to some of those other locomotion animations. But I'm only doing that for the locomotion animations. When we come back in the next video, you are going to see me start to create curves for our attack animations, for our hit animations, and we're also going to add some code to our audio collection player that's going to allow us to exclude certain layers. Now, I was hoping to do that in this lesson, but I've made a contract with myself that I'm going to try and keep videos to about 45 minutes. But as you can see, I've already completely broken that contract. So I don't want this video to go on any longer, so we're going to roll this discussion into the next video. But like I said, when I come back in the next lesson, we're going to start working on the other animations, and we're going to create all of the audio collections for those animations as well. Things like our attack sounds, our hit sounds, and some of our cinematic sounds, such as the feeding sounds. And we're also going to add some code that's going to allow us to exclude certain layers. So, for example, if we have a sound request on the base layer, but the cinematic layer is active, we can tell the base layer, don't play your sounds if the cinematic layer is active. Okay guys, so thanks very much for lending us your ears. I'll see you in the next lesson. Bye bye now.